If you're having problems getting accurate fixed ambiguity solutions, or if there's any other problem with your raw data, then using the GNSS raw data mode will help you to pinpoint the reasons for this problem. To do this, click on the GNSS raw data button at the top of the screen. You will see 5 available views for you to choose from. The first view is visible satellites, which allows you to analyze pseudo-range on L1C, L1P, L2C, L2P, and the carrier phase tracking on L1 and L2 of GPS and GLONASS data. On the chart, each satellite is displayed as a different color. A hole in the color bar indicates a disruption of the satellite's data, while a red bar through the line indicates a slip cycle. Slip cycles are only displayed on carrier phase data. On the parameters panel, you are shown the file name and path, as well as the type of receiver, your time data interval, start and end time, and duration. From a drop-down list, you can select a mask angle between 0 and 40 degrees above the horizon. You are also given the option of looking at data for either GPS or GLONASS constellations. You can select to show sites to overlay the time span of recorded sites that may appear in your file. And you can choose your observation type from a choice of L1C, L1P, L1 carrier, L2C, L2P, and L2 carrier. The next view is the number of satellites view. This chart displays the total number of satellites with an elevation higher than the selected mask angle. This is a simple chart and is often used as a quick reference to find out the number of available satellites. In addition to the file, receiver, time, mask angle, constellation, and sites options the previous view also gave you, you are able to choose which frequency you would like to view, whether it be L1 or L2. The SNR view is useful for analyzing the signal strength from a GNSS raw data file. This could help in detecting weak signal that can be generated using a bad antenna cable, bad connectors, or a poor observation environment. Low signal generally means high noise and may not generate the best positioning results. The parameters panel for NSR gives you the same options you saw for number of satellites, with the addition of GPS constellation. In this area, you can turn on and off satellite signals to exclude them from your analysis. The next view is the azimuth elevation view. This view displays a satellite's path in the sky during the observation time span. The horizontal axis represents the azimuth in degrees, with 0 equaling north, 90 east, 180 south, and 270 west. The vertical axis is the elevation labeled in degrees, with 0 equaling the horizon and 90 being the zenith. The parameters panel is very similar to the previous views, with the addition of GLONASS constellation, allowing you to exclude individual GLONASS satellites. The dot view tells you how spread out the satellite constellation is in the sky. The lower a GDOT value is, the more spread out the satellites are in the sky, and a good GDOT value should not exceed 8. The parameters panel displays similar options to the previous views. However, instead of GPS and GLONASS constellations, you are able to turn on and off the different types of DOP to exclude them from your analysis. The types of DOP that you can view are PDOP, which includes latitude, longitude, and height, GDOP, which includes latitude, longitude, height, and time, HDOP, which represents latitude and longitude, VDOP, which represents height, TDOP, which represents time, NDOP, which represents north parameters, and EDOP, which represents east parameters.